Welcome. As our guest on stage here has told me before, artificial intelligence is arguably the most important thing that's happening in technology right now. Generative AI is seemingly everywhere these days, and the newly emerging vertical is the talk of everyone in tech and VC. Meanwhile, synthetic data has gained popularity as a useful tool for the advancement of AI and machine learning. So to help us make sense of it all, I'm pleased to be joined here by Nathan Kundtz. He's the founder and CEO of Rendered.ai. It's a space capital portfolio company that has developed a common application framework to enable the production of physics-based synthetic data sets for AI training and validation. You may know Nathan from his previous role as CEO of Kymeta, which is a Bill Gates-backed metamaterials company that's building innovative antennas for next-generation satellite communications. Nathan also has a PhD in physics from Duke, and all of this makes him uniquely qualified to help us understand synthetic data, what it is, and why its generation is so central to artificial intelligence. Nathan, I know you have a lot going on, and so really appreciate this. Thanks for taking time out of your busy schedule to come in and talk to us.
It's my pleasure. It's a pleasure to be here and happy to talk.
Great. So we have just about a little over 20 minutes today and lots to cover. But to get us started, I mean, I think, synthetic data and generative AI is kind of all over the place these days. And so people are hearing about it in some shape or form. But with synthetic data specifically, now, I imagine not everyone is familiar with it. So can we just start at the beginning and sort of the basics, and can you help us understand what it is and why we need it?
Yeah, absolutely. So maybe just quickly reviewing kind of why we care about artificial intelligence in the context of space too, right? So a lot of this is happening because we have platforms that are generating massive amounts of data. Historically, that would be reviewed by humans, but there's just way too much by several orders of magnitude for that to be possible anymore. And so it requires us to use computer vision systems to make that possible. And artificial intelligence has really enabled that just to be done at scale and has become central to the use of a lot of different types of space assets. And so what I actually, after I left Kymeta, was seeing that happen, was seeing that trend and the impact that had on new space businesses, where someone who historically might say, hey, I've got a really great new sensor type, I'm going to be able to sell the data from it, suddenly needed to justify how they were going to generate insights in an automated way. And that really created a new engineering problem where, where historically they'd be able to say, hey, if my lens is this big or my reflector is this big, this will be my resolution. And that would be sort of good enough. Now they had to say, my ability to detect something is going to be this, and that was not possible. And the reason that's not possible is because to actually build those AI systems, you have to have a data set. In order to have a data set, they had to build the satellite, design the satellite, launch the satellite, collect data, and then build the artificial intelligence capability. And so that looked like a really foundational problem, and I dove in and really tried to understand how we could address that and start to pull artificial intelligence towards the types of engineering that we do in every other field, which basically, model-based design, things that are just standard everywhere else, but not possible in artificial intelligence. And so that became the genesis for Rendered.ai. And what we do is we use physics-based simulation, essentially at scale and in a controlled way that can be tasked by data scientists to build out data sets before systems exist and for scenarios which maybe they otherwise wouldn't be able to detect. And so we've been at that for a couple of years now and doing that with NGA, Orbital Insight, Planet's using us for hyperspectral, their next generation constellation of satellites, as well as a variety of other lighthouse customers in the satellite industry. And so we're really seeing that trend where there's a recognition that you can't just build AI and hope for the best with the data you have. You have to get control over that data and make it part of your engineering process.
That's great overview. And so how are you helping people to do that? What is it that you're building actually? What is it that you're building and selling and people
Absolutely. So certainly we're not the first people to go, think about simulation of sensor outputs, right? That's been being done for many, many decades. But what you find in the industry is there's a couple of gaps. It's easy to go, hey, if I've got a good simulator, then I'll have good synthetic data. But the reality is those simulators are typically driven by people with deep domain expertise in the modalities they're talking about. Like if you're simulating hyperspectral sensor, like you are a hyperspectral scientist, you probably have a PhD in that. And the overlap between that skill set and a computer vision skill set from an individual standpoint is basically nil. There's nobody actually has both of those. And so what we do is we create a complete framework to close the gap between those two communities, right? So that we can take people with, let's say, hyperspectral or synthetic aperture radar or other EO modeling expertise. They deploy applications to our platform. Those applications can be tasked by computer vision users to control, which can then control the data that's being generated in a way that makes sense to them. And then that data is delivered to them in our platform, which also includes tools for things that would be obvious in any other industry, but are not sometimes in AI, like quality assessment, right? Like, hey, is that data any good? Is it actually doing what you think it should be doing? Right? It sounds obvious when you say it, but it turns out no one else is doing that or even thinking about it. And so, that, as well as history, librarianship, and tools that allow people to collaborate, because of course none of these programs are sort of one person sitting at their computer building out these systems. These are all being done by teams of engineers.
So you take out all the heavy lifting and sort of make it easy for the folks at these companies, these enterprises and government customers to leverage synthetic data without having to build it from scratch every time.
Yeah, exactly. Right. So if you wanted to do that from scratch, right, even if you had a simulator, you still need 3D modeling capabilities. You need procedural effect generation capabilities. There's a whole suite of sort of Hollywood style knowledge that you would need to have resident. You need a fabric on which to deploy that. You need volume management of what can be hundreds of gigabytes or more of assets that need to be deployable into those environments. You need to be able to set up a high performance compute environment, because then you need to build data pipelines into what your computer vision engineers would need. You need some sort of a tasking system to make that work. And the point is, I don't need to list all of the things. There's a lot that ends up being required if you want to actually build out a system that's going to be functional and allow you to iterate and engineer. And that's beyond the capacity of 99.9% of the organizations that actually need synthetic data.
Right. Okay. And then so you say that Rendered enables the productions of physics-based synthetic data. Why is that important? And how is physics-based different than the alternative?
Yeah, that's a great question. So when we say physics-based, what we're really talking about is sort of where does new information come from, right? There's this, for those who want to like study Greek, there's this epistemological question about like, how do we know what we know? And usually physics-based is in contrast with generative. So with generative tools, we know things because we've just seen them a lot. There's a joke. Ernest Rutherford, a turn of the last century physicist, said, all science is either physics or stamp collecting. So generative is sort of like stamp collecting at a really massive scale. Like, what if we had 100 billion stamps? Like, what changes? And that's phenomenal. Like, there's a lot of good that happens there, but it's not everything, right? It's still kind of recombinations of information that exists. And with the physics-based, what we're able to do is actually essentially generate new information, because we can actually ask the question, in this scenario, what would we see even if we've never seen a scenario like that before? And it turns out what we actually find works best is combinations of those two, as you might imagine. If you only do generative, you're sort of not introducing new information. There's a lot of good use cases for that, but it doesn't help you with the rare events and edge cases or novel engineering that our customers really need. If you only use physics-based, you can be, let's say, like over specifying the system, right? Like backgrounds and textures and materials are sometimes, it's great to have generative because you can create a lot of diversity really, really easily, but then you still pass that through a physics-based simulation to actually generate new information.
So they say, maybe you said this actually, that the explosion of generative AI has both increased and confused interest in synthetic data. Like, how do you Is that true, or is on the whole, is it a positive?
Yeah, I mean, on the whole, it's generally positive. I mean, we've seen customers, it's early market dynamics. So we see a customers that run the gamut from like don't even understand the difference between generative and simulated data. We actually see a lot of the folks that are coming to us, frankly, have tried generative at this point. Because keep in mind, we're doing imagery, so they've already used Stable Diffusion or any number of those other tools for image generation, and come to the conclusion that that can't help them. And so now they're looking for a more sophisticated solution to actually address their problems. And so that's that's out there in the industry too. I think it's really shown a light on, like, how should I say, once you kind of catch the bug of I want to be able to generate data, you realize you have to have that, and it has driven customers into the market to go figure out how they can do that in an effective way. So it's been good for us. But there is noise is maybe a strong word, but there's a lot of, I'd say, churn in the market around the tool because the technology is moving so quickly.
Yeah, and there's and it's relatively new, and the market is well, let's start with that. I mean, it's growing very rapidly, as is AI more broadly. What is driving that? Do you think? Is it we talked about it a little bit, but is there other things in there that you think is driving this market forward? And how do you think about the potential, the overall market potential for what you do?
Yeah, I mean, it's interesting. If you look at these markets, the reality is, as much as we've been talking about AI for a long time, AI is not as widely adopted as it will be, not by a long shot, right? So like computer vision tools in most of these industries are still in kind of the early days of wide scale adoption. And as that happens, and as you go from, I would say, if you look at kind of the recent explosion of AI, maybe starting in kind of the 2015 timeframe, as we started to really see deep neural nets expand rapidly, there was about 4 or 5 years there where essentially it was just magic. And you got a bunch of people showing, hey, we got this magic thing, but then they would go try to deploy it. And it's like, well, it doesn't work as well as we thought. And it was really hard. There were a lot of people who actually thought it would all die. Like, oh, it works, it's great. You can publish a paper, but it doesn't turn into anything real. And what we're seeing actually now is this second wave where those applications are being deployed into the real world. And maybe I'll pick one of our recent customers that's not space, just because it's really kind of it drives a point home. But like, we're working with BNSF, which is trying to improve their computer vision system so that they can avoid train derailments. Well, frankly, that's got to work, man. Like, it's not, that is not a magic trick. That just has to work. And when it has to work, you need engineering tools that can help make that work in a consistent way that you can be confident in. And it is that market force that is driving people, I think, to the sort of sustainable adoption of synthetic data.
I like that a lot. And then you've said before that AI is it's just coding with data, and that synthetic data is the only thing that gives people control over that data set. So as it's AI is now, the use cases and the applicability is growing at an incredible pace. People are wondering where it's going and how we can understand this and get our arms around it. And you're saying that synthetic data is the only thing that gives people control over this data set.
Yeah.
Can you expand on that a little bit?
Yeah, absolutely. I mean, I strongly believe this, right? So I sometimes joke that AI is spelled SOFTWARE because it's just software, right? Like, it's just software at some level. And yet for some reason, our expectations of it are so different than any other form of software. It's true. Like, we don't code it, so, we code with Python or something, but all the performance is driven by the data sets that you have access to and how they're constructed. And we also sometimes treat AI as if it's going to be this monolithic, code base that never gets changed, like as if this is the first form of software that doesn't have bugs, which is, of course, also not true. And so, but now, if you want to fix those bugs, if you want to improve performance over time, you can't do it anymore by going back to the code. The code didn't create the bugs; the data created them. And so, if you can't start and it's controlling the data, it's also understanding the data. If you have a data set of 1 million images, you don't know what's in that data set. Like, you don't actually know at depth what's really ground truth in those images. And that's how you end up with things like bias, unintended, or otherwise. And bias can mean all sorts of things, right? Like, we talk about racial bias, but there's also, the most common form of bias is just that we see a lot of the same thing all the time, and we don't see sort of rarer things, and that causes these algorithms to over key in on those. So once you get control of that data, that actually enables you to engineer. And I don't know of any other way to do it other than you've got to get back to how do you know what you know? How did you generate that data in the first place, such that you have confidence in what's there?
Okay, so I'm excited to dive into some of these use cases. I think this will be the most interesting part of this conversation. So I mean, we've been obviously following your progress very closely, and it's been really exciting to see how far you've come in just a few years, and actually how much faster this growth has sort of come, given that synthetic data is a new technology, and the market required some education as to how it can help them. You go in and you have a conversation with the C-suite of basically any company that's using AI or computer vision or ML at all, and you explain to them what synthetic data is and how it can benefit their business, and suddenly, like, oh yes, of course we need this, right?
Yeah.
But they don't know that right out of the gate, right? And so there was what I thought was going to be a pretty large adoption curve. To sort of get past that, you zeroed in on some customers who did understand the benefits of it and were excited about it from the get-go, which is geospatial satellite companies. I mean, this is a new technology, but meanwhile, up until yesterday, publicly traded Maxar, their CEO, was out saying that synthetic data is the new gold, because they saw the value in it. So I'm curious, if we can take the conversation to a place where, like, how is that, how has geospatial Earth observation companies, like, helped in being your beachhead market? And, can we talk about some of these other use cases that you're now getting into?
Yeah, absolutely. So, I mean, and I should mention that Maxar is a partner, so that's we feel good about that, and the fact that the CEO thinks synthetic data is gold. So we were very intentional about starting with satellite imagery. I mean, as you know, Chad, we talked about this really early in the genesis of the company, and that was because we saw this industry as the people that were really facing these engineering problems first, and that was on a federal national security side. Obviously, like, detecting things is crucial, and the things that need to be detected are rare, and not doing it right has really terrible consequences. And so there's a lot of demand there. But then on the commercial side, right, everything from crop monitoring to what are we going to be doing? We were also looking at, hey, okay, synthetic aperture radar is now available commercially, hyperspectral is coming commercially. So we were watching this, not just a plethora of satellite data in some sort of general sense, but really differentiated sensing capabilities coming to market, and then talking to people about how they would adopt, and they were like, we don't know. Like, a lot of people were like, we have no idea how we're going to adopt. And so we saw that as a tremendous market opportunity, and it has been. So we've gotten some really good adoption across this industry, and what that's allowed us to do is get these proof points of how people really get value from synthetic data, and that in turn has really enabled us to then expand into other industries. So there's a few things here that are kind of worth calling out, in my opinion. You've got so things like synthetic aperture radar. So we've worked with the Japanese government to detect ships at sea. They have obviously an interest in being able to track vessels under cloud cover. We've done a lot with just general RGB Earth observation and object detection. I've mentioned a couple of times, I think, Planet and the hyperspectral constellation. So that's for methane cloud detection, but also they've got demand in mining and agriculture there, and so we're helping provide data sets. In fact, if you sign up for the Planet Early Adopter program, you get a data set that was generated using Rendered.ai, and so that's kind of cool. We'd see demand and then have customers that are using the platform for different types of security imaging. for obvious reasons, wanting to be able to detect things. But we're also working with folks like Procter and Gamble on removing racial bias from consumer-facing kind of medical care applications. We're working with a company detecting weapons that would otherwise enter into the schoolrooms. And so, these types of things, and then you add the BNSF relationship and helping to eliminate train derailment. Yeah, we feel really good about how the company has started to address these really, really crucial problems. It's one thing to sit up here and say like, yeah, you need control over your AI in some generic because you're a good software engineer sense. And it's a totally different thing to say, hey, you need control over your AI because I want to keep the gun out of my kid's high school. How about that? Right? It's a very different feeling. And yet that's really what it is, right? That's what we do.
I mean, it's fantastic. This is and this is just scratching the surface of what's possible. I mean, I've even seen since you first introduced me to some of these use cases, a couple of weeks ago, the company's put out a LinkedIn article talking about how physically accurate synthetic data is transforming the way we can identify and mitigate forest fires. You're using synthetic physics-based synthetic data of smoke plumes, right?
Absolutely. So, I mean, the forest fires, I think, is a great example, right? Like, you don't want to go light forest fires in order to build up a data set to go figure out how to detect forest fires, right? It's a bad idea, and they just don't happen that often. And so, you do need to be able to generate data, and then you also need provability that you can detect them, right? Like you can imagine the inverse problem, which is how confident should you be that whatever detection system you have set up will in fact work when it counts.
That's why I'm so happy that you were here today, that Rendered is a portfolio company of ours. I mean, if you look at the opportunity here, and these are your words again, but I really like them, that the market opportunity for Rendered is AI, the entire AI market. And it's not just where AI is, it's where AI can go. So this is a massive opportunity that's going to touch an infinite number of industries. You've got these types of applications that have real human benefit and are very impactful. You add those two things together. And then you've also got some really, really tangible benefits to business. I mean, you mentioned SAR, and we kind of breezed over this, but this radar imagery is very difficult for humans to process. It's also very expensive.
Yeah.
If you want to train your AI on real SAR imagery, it's going to cost you a lot of money, because each one of those images costs thousands of dollars, and you need how many images to train your AI? So yes.
Yeah. So there's a video playing right now, and I think it says synthetic aperture radar on it if you guys take a look at it. But like, that's made from over 300 simulated synthetic aperture radar images just to produce that video, and you can see how much that one object changes based just on its orientation. Right? There's a lot of other things that are held constant throughout that video. It's just what happens as you rotate it. You need a lot of that kind of data before you can train an algorithm. And each image in this case would cost something like $5,000 if you were to try to actually buy that. And not only that, you'd have to take this ship out into the middle of the ocean and rotate it around, I suppose, while you waited for the satellite to come around. Like, it's actually, like, we can talk about it like, oh, you could do it for $50 million and we're cheaper. Like, I guess that's true in some academic sense. The reality is it's not possible. There's really actually no other way to get that kind of information in order to be able to do that kind of detection.
Nathan, we're out of time, but this has been a fascinating conversation. I really appreciate you taking the time to talk to us.